All right, let's do Unit 4 here. We have composition of functions. We work our way, it's like a puzzle, we work our way from the inside out. So for A, we need g of -2. So let's do that. G of -2 is equal to, and then our g of x, all we have to do is replace each x with -2. So I'm going to rewrite -2 times -2 squared. Now you guys have to be really careful here. I'm going to show you something on the calculator. If you just type in -2 squared, it's going to give you -4. That is not the correct answer. The calculator is doing 2 squared and then multiplying it by -1. It's using its order of operations. In order to put it in the calculator, you have to put, or just know that if you square a negative, it's going to be a positive. But if you put a parenthesis around the -2 and then square it, it's going to give you the correct answer of +4. So don't make a rookie mistake because your calculator gives you a -4 if you're squaring a negative number, okay, because it's going to mess up your entire answer. If it's this easy, try to do it in your head because you don't want a calculator mistake. So what that ends up with is -2 times -2 squared is 4. And our final answer for g of -2 is -8. Now we're not done. We have to go back in, and now we have to find f of -8. Okay, because first we had to find out what g of -2 was, and now we have to find out what f of that answer is. So instead of an x, I'm going to put -8. So now I have -8 over 3, and I'm going to add 2. But it's a fraction, so I need to change 2 to have a denominator of 3. So if I multiply it by 3 over 3, I get 6 over 3, which makes sense because 6 divided by 3 is just 2, right? So then I end up with my final answer, which is -2 thirds. So the answer for A is -2 thirds. Okay, let's erase this and do B. So we need to do g of 5 first for B. So what does that look like? That looks like g of 5 equals -2 times 5 squared, which is -2 times 25. So the answer to g of 5 is -50. So now we need to find h of -50. So h of -50, I'm going to rewrite the equation for h, but everywhere there's an x, instead I'm going to put -50 minus 2 squared. You guys were really good at remembering that you need to do the inside of the parentheses first. However, most of you were pretty terrible about remembering how to add and subtract negative numbers. So -50 minus 2 is -52 because I start on the number line at 50, okay, and then I go backwards 2 more. Then if you square that, you're going to get a positive answer, and it's going to be 20, oh God, I can't remember. Let's do it. -52, oops, I'm just going to do 52 squared because I know my answer is going to be positive. 2704, 2,704. Okay, so make sure you have all those little things down. That's going to be the stuff that's just going to trip you up on the test that doesn't need to be tripping you up. And then last, g of f of x. Okay, so it's the same thing. It's just that we can't really simplify it as much down to one number. So f of x is, what we're going to want to do is we want g of, and instead of f of x, we want g of x over 3 plus 2. So in g of x, I'm going to rewrite it, but where the x is, I'm going to leave a really long blank space, okay? So there's my g of x, but instead of x, I'm just going to put all of f of x, which is x over 3 plus 2, okay? So g of f of x is negative 2 times the quantity of x over 3 plus 2 squared. Okay, so it's just going to be a parabola that is stretched horizontally, stretched vertically, reflected across the x-axis, and to the left too, right? So we can also practice those transformations. Ooh, another unit 4. Which of the following relations are functions? So we need to think back to our vending machine and our vertical line test. So it's always easiest to see it as a graph, because you can just do that vertical line test. A vertical line is, forgive my vertical lines here, but it's only going to cross once, right? So this is a function. Yes, it is. Exclamation point. Yes, it is. Vertical line test. If it asks for justification, you need to say because of the vertical line test. Now, just really quickly, if we had something like this, this would not pass the vertical line test, right? It crosses twice, so it's pretty easy to see. Here, when we have this kind of table, this is where I like to think of the vending machine. I'm going to the vending machine at 1 p.m., and I'm going to press 6 for, I don't know, Snickers. Maybe Snickers is 6, right? That's cool. I can do that. Then I'm going to go at 2 p.m. exactly, and I'm going to press 5, and that's going to give me, I don't know, Pop-Tarts. And that's cool. Then this one says I'm going to go to the vending machine at 3 p.m., and I'm going to press both 6 for Snickers and 7 at the same time for, because you want something sweet and salty, maybe pretzels. Did I spell that? Did I spell that correctly? Pretzels. But you can't. You cannot have 2 come out at exactly the same time. If this is the 3rd time I'm going to press a button, I cannot press 2 buttons at the same time. So this is not a function. But what if I wanted to, let's see, I already got pretzels at 2, but what if I came back at 5 and I bought pretzels again? That's okay. You can do that. But this is not a function because we tried to press 2 buttons at the same time and we broke the machine. Okay? And then this one, if you can't tell if just the equation like this is going to be a function, my recommendation, put it into your calculator, and then then you can get a graph back, and then it's going to be really, remember we said it was easy to tell for a graph if it's a function or not by the vertical line test. That would be my suggestion for this one. Obviously, this is just a linear relationship, 3 with a slope of positive 3 and a y-intercept of negative 1, and a linear relationship is a function. What's next? Oh, good, some more of these. These are fun. All right, f of 3. So f of 3, I'm going to rewrite the function of f of x, but everywhere I see an x, instead, I'm going to put a 3, so negative 2 times 3 plus 4. Negative 2 times 3 is negative 6 plus 4. My answer is negative 2. G of negative 6, I'm going to rewrite g of x, but everywhere I see an x, I'm going to instead put a negative 6. So on the numerator, I have negative 6 plus 3. On the denominator, I have negative 6 minus 5. Negative 6 plus 3, I have negative 3 on my numerator. On my denominator, negative 6 minus 5 is negative 11. So my answer is actually positive 3/11. Okay? You could put negative 3 over negative 11, but mathematicians don't like that. They like it clean, and they don't like negatives on the denominator a lot. So if I know this is positive, you're just going to write your answer as positive. F of 7 plus f of 0. So f of 7, let's do that one first. So if we go up to f, if we had a 7 here instead of x, we get negative 14 plus 4 is going to be negative 10 plus f of 0, so if I put 0 here, that would be 0 plus 4b, just positive 4. So that answer is going to be negative 6. Okay. And then this last one, is it, oh no, let me see if I can find it really quick, you guys, hold on. That last one says, what is x when g of x equals 0? So if g of x equals 0, we need to solve for x. So in this case, I'm going to erase some stuff here, you guys. And I think this was confusing to some people, but hopefully if you watch this, it'll become clear. It says g of x is 0. So instead of writing g of x right here, I'm going to write 0 is equal to, okay, so I have 0 is equal to x plus 3 over x minus 5. And now I want to solve for x. So I'm going to multiply both sides by x minus 5. I can do that. That's okay, as long as I do it the same thing to the other side. Okay, and here it cancels out. Those just cancel out because it's the same exact thing on the numerator and the same exact thing on the denominator being multiplied, right? And then over here, anything times 0 is still 0. So all I have left is 0 equals x plus 3. So some number plus 3 is 0. Obviously, if we subtract 3 from both sides, we get negative 3 equals x. So x is negative 3. Okay. Ooh, another unit 4. Oh no, I think this one may have gotten cut off too. That's okay. We can kind of, oh, we just can't see C. We'll do as much as we can. I feel like we just came off a unit where you guys did really well on this, so it shouldn't be too strenuous to do this one. There we go. I think I've gotten them all there now. So a lot of you guys, I noticed on when we were doing this in class, we're calling this f of the absolute value of x, which it is not, only because it has this kind of like curling. This is a piecewise function, if anything, but what you need to know is it doesn't really matter. It doesn't really matter what the equation of the line is as long as we're stating what it's going to do. Okay, so here's the original one, and the vertex, it looks, is down here at like positive 1, positive 2. So for A, what has happened? It was here, and it looks like it just moved down 1, 2, 3. So f of x, and then on the outside, we put minus 3. And that means it moves up and down if it's on the outside of this function, okay? This is our output, so this is our y value. Our original y value was positive 2, right? And then our new y value is negative 1. So we have, if we took that positive 2 and we subtracted 3, our answer would be negative 1, okay? But the way you actually write it is f of x. The x is inside the parentheses, and the minus 3 is on the outside of the parentheses. Okay, this one, it looks like here was the vertices. It looks like we haven't done anything except move it over to the left too. So if you're moving it horizontally, we're going to do f parenthesis x plus, remember we have to do the opposite. This is going to the left, but we're going to put plus 2. Okay, and then it doesn't look like it's moved up and down or down at all. So it's just f and then x plus 2 in the parentheses. So you see the difference? If it's on the outside, it's moving up and down. If it's on the inside of the parentheses, it's moving side to side. And then on the last one, we haven't done any stretching or shrinking, and we still haven't, but we have moved it to 1, 2, 3 to the left and down 1, 2, 3, 4, 5, 6. So to the left 3 is going to be plus 3. I know that seems so weird on the inside, and then down 6 on the outside. And we're just using parentheses. It doesn't matter what the function looks like, okay? If it was just the absolute value, instead of parentheses, they would be the absolute value. Ooh, state the intervals where this is increasing or decreasing. A bunch of you are confused and mad, and I get that, and that's because At the end of the function over here, I didn't have a point and I didn't have an arrow. So you're kind of like, well, is it going on forever or is it not going on forever? You can do it both ways. In my head, I was thinking it is increasing from negative infinity, right, to 2. And it's also increasing from 6 to positive infinity. Okay, so it's increasing from 6 to positive infinity. And then in between there, it's decreasing. So from, oops, this is kind of weird. So this is where it's increasing. And it's decreasing from 2 to 6. And you always want to write the numbers in numerical order. So my 2 came first because it's smaller than my 6. My negative infinity came first and then 2. My 6 came first and then positive infinity, okay? And this is where it's decreasing. Now, here's something interesting we didn't really go over before, and I'll try to remember to do it before the test, but at the actual point of where it's changing right here, from increasing, and now it's decreasing. This is neither increasing or decreasing. It's neither point, okay? And that's why we just have open parentheses, or we just have, open parentheses instead of closed parentheses, which would be the square ones. Okay, but you guys did really well on that. If it was a dot, this would have been whatever number it was, and it could have been a closed parenthesis. Well, you don't really know what's happening on the other side of it, but if it's just a dot, a closed parenthesis. Okay. Jamal observed vehicles passing through. Oh, this is unit 3. You know what? I'm going to stop and do this as a separate video.